Out among the billions of stars in our galaxy, objects are always moving. Planets orbit, comets swing by, asteroids roam, but rarely does something cross the boundary of our solar system. Something born somewhere else entirely, venturing into our neighborhood on a one-time pass. In July 2025, astronomers detected just such a visitor, 3I/Atlas. The third confirmed interstellar object to pass through our solar system after Oumuamua and 2I/Borisov. At first, it seemed another icy wanderer, a cosmic snowball with dusty trails. Yet with each new observation, its behavior began to diverge from expectations. Now, many in the scientific community whisper that something weird is happening with 3I/Atlas. A strange mix of chemistry, trajectory, brightness, and anomalies that challenge what we thought we understood about objects traveling between the stars. 3I/Atlas was first discovered on July 1st, 2025, with the Atlas Survey Telescope in Rio Hurtado, Chile. As data piled up, more telescopes joined in. Hubble, Webb, the Zwicky Transient Facility, and others. Pre-discovery images were found, extending its observed path and revealing something fascinating. Its orbit is strongly hyperbolic. It is not bound by the sun. It is passing through. Even early on, astronomers noted something unusual in the shape of its coma, a teardrop-like dust envelope drifting from the nucleus, asymmetrical, dynamic. The comet appears active even far from the sun, where heat is low and sublimation of ices should be weak. Observations from JWST revealed that the gas coma around 3I/Atlas is unusually rich in carbon dioxide compared to water. The CO2/H2O ratio is far higher than what we usually see in comets visiting our solar system. This suggests that either the object formed under different conditions or its volatile inventory has been altered uniquely. Classic comets behave in predictable ways. Frozen ice vaporizes as sunlight warms them. Gases and dust escape, forming a bright coma and a glowing tail that streams away from the sun. But 3I/Atlas is not following that script, or at least not fully. Its tail is faint or inconsistent. Some observations suggest coma activity very far from the sun, where solar energy is weak. Its brightness is higher than expected for its size, implying a surface more reflective or dusty than typical comet nuclei. Another oddity, polarimetric measurements, which probe how light is scattered by the dust and gas, show a deeply negative polarization branch at small phase angles, something not previously seen among comets and asteroids. In other words, the way 3I/Atlas reflects light is off from what we thought possible for such objects, especially in both near sunlight and distant regimes. AR-14. Also, the comet appears to be shedding CO2 and showing outgassing preferentially in the sun-side direction, more so than typical comets at that distance. Water vapor is present but weak compared to CO2. These chemical fingerprints suggest a nucleus either unusually rich in CO2, perhaps formed near a CO2 ice line in its parent protoplanetary disk, or with inhibited water vapor due to surface insulation or crust. Beyond chemistry, the path and size of 3I/Atlas raise more questions. Its hyperbolic trajectory confirms it won't return. It's a visitor, not a resident. But its motion is unusual even for interstellar passers-by. Its speed is high, its path steeply inclined, and yet in some reports, its plane of passage appears to align in surprising ways with our solar system's ecliptic, a statistical oddity. As for size, estimates place its nucleus diameter between 440 meters and 5.6 kilometers, with upper limit estimates perhaps larger depending on assumptions about reflectivity and brightness. If closer to the upper end, it could be the largest interstellar object we've ever had detailed observations of. Age is also under discussion. Some astronomers have hypothesized that 3I/Atlas may be significantly older than our solar system, potentially billions of years older, originating in a star system very different from ours. Its journey through interstellar space would have exposed it to radiation, cosmic dust, and temperature extremes, all of which might help explain its unusual composition. So what are the possible explanations for these anomalies? 1. 3I/Atlas is a weird comet, with a composition and structure unlike typical solar system comets, formed under different conditions and preserving ancient, volatile-rich material. It may have formed in a cold, radiation-exposed environment, giving it a high CO2 content and less water vapor. 2. Its surface may be coated with a crust or insulating layer that suppresses sublimation until it's heated more strongly, which can explain late-onset activity or unusual brightness. 3. There could be non-gravitational forces at play, for instance outgassing jets producing subtle acceleration or orientation effects of dust and gas that change how we see the comet. Some physicists are considering if some activity is being switched on as it warms, meaning the comet's behavior changes dramatically once certain thresholds are crossed. Then there are more speculative ideas. Could this object be partially artificial? Could it be a fragment of a disrupted body from another star system with exotic materials? Or might it be some form of debris that doesn't quite conform to our categories of comet or asteroid? But no solid evidence yet supports artificial origin, and mainstream science remains cautious. The anomalies are real, but nature has surprised us before. Because 3I/Atlas is passing through, never to return, astronomers have mobilized quickly. Telescopes across the globe and in space. Hubble, JWST, SOFIA, spacex, and many more are tracking it, measuring light curves, spectra, coma composition, tail development, and polarization. Every data point helps refine our models. The flyby past Mars in early October 2025 offers a chance to observe from spacecraft stationed around Mars. It's perihelion. The closest approach to the Sun is expected around late October. Afterwards, it will move outward, allowing for renewed observations once it's past the glare. These observations matter. They can tell us about how comets and icy bodies form in other star systems. They provide clues about volatile chemistry far from stars. They test our understanding of comet dynamics, outgassing behavior, polarization, dust properties, and the variety of objects that drift in interstellar space. The story of 3I/Atlas reminds us, the universe is stranger than our models. Our categories, asteroid, comet, interstellar object, are approximations. They help us classify, but sometimes get in the way of seeing exceptions. If 3I/Atlas is truly an outlier, what does that say about what we thought normal was? Are there many more objects like this, too faint or fast for us to detect? If so, we might be missing whole classes of interstellar wanderers. If any of the more speculative possibilities are true, if its composition, brightness, or behavior point towards something partially artificial or techno-influenced, then we would need to confront very large questions about life, technology, and our place in the galaxy. But, and this is crucial, extraordinary claims require extraordinary evidence. For now, it seems likely that nature is showing off. Nature throwing a curveball. So as 3I/Atlas hurtles through our solar system, leaving our sun's gravity behind for the final time, it carries with it traces of its origins. ice, dust, carbon dioxide, perhaps even water, all relics of ancient star systems, offering whispers about what life there may be like and how celestial bodies form under radically different conditions. We are watching as data streams in. Telescopes click, spectrographs hum, light curves etched into CCDs. Every anomaly logged, every unexpected reading held up for peer review. Someday, long after 3i/Atlas is gone, we may look back and see it as a hinge in our understanding. The moment when we realize that interstellar visitors are more varied, more weird, more fascinating than we ever dared imagine. Because the real wonder isn't just that something came from beyond. It's that we saw it, studied it, questioned it, that we allowed ourselves to be surprised. Something weird is happening with 3i/Atlas, and it's up to us to figure out what.